Hello again. My name is Josh Winchell. I'm an associate research scientist, assistant research scientist here at Texas A&M's High Performance Research Computing. And today I'm going to be telling y'all about our composable computing cluster ACES. Also maybe faster if we have time, we'll see. We have two clusters that are composable, faster and ACES. Faster was sort of the precursor to ACES. So now that we have the newer, bigger, better thing, we're mostly going to focus on ACES. So here's a brief outline of what we'll be covering today. First of all, what is composability? What's the point of these clusters? We'll have a brief overview of all the things that ACES has, composability and accelerators and hardware and such. We'll have a section dedicated to how to make use of that composability and accelerators, brief overview at least. I'll point you to some more involved documentation and training if you want to know more about the things I talk about today. There will be, and then these last couple of sections will be showing general cluster usage on ACES, getting started, basic policies, the software infrastructure we have, batch computing, etc. So to start off, this is intro to composable clusters. What is composability? In broad strokes, comparing older traditional systems to the newer stuff we're trying to push towards, more standard computers are very static, very fixed. You put all your hardware in a box, and that box stays just like it is forever. It's like a Lego set you glue together when you're done. Looking forward, we want to do something more flexible than that, and also something more powerful than that. So we are building clusters built on disaggregated hardware that are composable, that is like modular, movable. If you have, say, a big, heavy AI model, we want to be able to like pull all the resources you need all together in one place instead of requiring you to like split it up into small little chunks across multiple nodes or something. This little cartoon here demonstrates sort of what we're trying to do. On the far left, you have your traditional old school server configuration. Again, you have these set, static, fixed computing nodes. This one has two physical slots for GPUs and some SSD space, and that's all that will ever go into it. It will always look like that, unless you want to like dig stuff out of it and replace things, which you don't want to do. Better, we think, is if we just have all our resources in these pools, a server pool, an accelerator pool, storage and memory pool. We can hook those all up with this liquid fabric, and then from these pools, we can construct or compose nodes with whatever resources we want. So do you want 14 GPUs? We can do that. An actual normal physical node wouldn't have space for that, of course, but we can compose a node like that. Maybe you want to mix up accelerators even, have FPGAs and GPUs. We can do that. You want extra memory on your node. We can compose those in as well. So this is the gist of what we want from composability. It can be both more flexible and more powerful since it's not limited by whatever fits inside a given box. So this is how we get to ACES, faster and ACES, but mostly focusing on ACES today. Faster came first. It was sort of set up for ACES. ACES now has all the like fancier hardware. You can still get on faster. We'll talk more about that later if we need to. But for today, we're mostly going to focus on ACES. So ACES stands for Accelerating Computing for Emerging Sciences. If it were up to me, I would have given it an acronym that was less similar to ACES and ACSS, but oh well, this is what we have. The mission of ACES is to be an NSF ACSS cyber infrastructure testbed. We're thinking mostly of providing a test base for like AI ML workloads. Again, you can get a composed node with 14 GPUs if you want, which could be really good for a big heavy-duty AI model with a bajillion parameters. We want to support researchers getting up and running on those and collaborate on computational and data-enabled research. This is what ACES looks like. It's in a building that looks like this, and this is ACES itself. It's very pretty. It's very cold. I won't dwell on this. This is a diagram of the current hardware configuration of ACES. I'm also not going to spend a lot of time on this, but if you want to check again, you can come back to this slide for reference later. Oh, these slides, by the way, these are posted online. Let me show you that real quick. From our homepage, hprc.tamu.edu. You can go to the training tab, courses, and there will be a card down here for this course. Yeah, here, Introduction to Composable Computing on ACES and Faster. You can find these slides linked down here, fall 2024, and also some older materials as well for reference. All right, keep moving. So again, some more kind of reference slides, and I'm not going to read all of this. Refer back to these if you want to know more about details of what all is on ACES. See also our knowledge base, which will have some more information as well. While I'm at it, I'll show you where that is. Back on our website, the Zoom controls are in the way. Here we go. Back on our website, this W up here, this will take you to our knowledge base. It looks like this. We have quick start guides for all of our clusters, including ACES. And for more detailed information, go to the user guide section, and we've got this ACES section here with hardware, access, yada, 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 whatever you need. Okay, back to the slides. Again, not going to read through all this. I guess the highlights, we got a bunch of nodes, 2 gens of composable infrastructure, Lustre as a file system. These I will spend a little more time on in the coming slides, not this particular slide, but these are the fun accelerators that we have on ACES, most of which can be composed to, a node if you want. We've got graph core IPUs, we've got 2 kinds of FPGAs, next silicon coprocessors, NEC vector engines, Intel Optane SSDs, which is perhaps not an accelerator per se, but I mentioned we can compose memory. We do it with these. 2 kinds of NVIDIA GPUs, H100s and A30s, and also a bunch of Intel PVC GPUs. I'll come back to these in a moment. Final reference slide, I guess. This is the system software stack. Note that we're using Slurm for our job scheduler. I'll be talking about that in our examples later. I will be talking about our Open On-Demand portal, which it provides our web interface. Let's keep moving. So, I believe in our audience, both today and people watching this video later possibly, we're going to have 2 groups of people. Group 1 is HPC experts who already know how to do basic, cluster computing, batch computing, and they just want to know how to get to the fun things on ACES. That's what this section is going to be here. I suspect also, though, there's going to be some people who are newer to HPC and cluster programming or cluster computing, and they want to know more about how to use ACES and clusters generally. Most of this talk will be for the latter group, for new people. First, though, I do want to show y'all how to get to the special things on ACES so y'all experts can see this part and then bounce if you have to. So, brief section here, composing and using accelerators. How do you take advantage of ACES being composable and such? So first of all, how do you get to ACES? You'll need an access ID already. I think most of y'all have that in the first place. We advertise that in advertising this course with an access ID. And once you've gotten an account set up on ACES, contact us with that, of course. You will get there from our homepage through the portal dropdown. It'll ask you to log in through Access and your institution, and that'll drop you off on our Open On-Demand portal. Once you're there, assuming you want to get to the shell quickly, there will just be this clusters tab up top with ACES shell access, and that will get you the shell. I'm going to go ahead and demonstrate that really quick. Hold on. Okay, so yeah, back on our homepage or any of our HPRC pages, go to this portal drop-down tab here. Don't click on the tab. That takes you inside the A&M firewall, which y'all can't all do. Go down to the ACES portal, access. It will give you this access login here. Question chat, what if you're joining from outside TAMU? So ACES is accessible to people outside TAMU. It's just like clicking on this tab itself. It'll take you to this page. I come to this page here because I'm inside the A&M firewall. If you try to get to this particular page, it won't let you. So just hover over the portal and then come down to the ACES portal. You should be able to get it here. It will take you to, oh, I see an error. Okay. So, hold on. So you get to this page, it asks you to log in with access and with your institution. And somewhat embarrassingly at the moment, I think some of y'all have, hit this. So this is embarrassing. This error started showing up like right before class, and the admins haven't had time to troubleshoot it yet. Yeah, we're working on it. I'm sorry, it jumped us really recently. Sorry about that. I was hoping to have some interaction here. If need be, I will try to jump over to faster, which will work kind of similarly, so I can at least demonstrate the things I'm talking about. I apologize if y'all aren't able to follow along, because again, this like just happened. We apologize for that. We're working on it. I'm watching Slack in the background to see if someone says they have a solution. Not sure we do right now. Okay. Well, apologies again. Let me know if you have questions, and I'll try to demonstrate whatever's happening as best I can. So once that error is solved, to get on ACES, you'll log in as I just showed you. You'll end up on an on-demand portal that looks like this. I wonder. Let's go ahead and check. Can I get onto faster? Okay. I wonder if it's an access error. Can I get onto faster with A&M credentials? You will. Okay, I can. Y'all won't all be able to do this, but this is just for sake of demo. Getting on ACES will look something like this. Once you've logged in through Access, you'll be on a portal that looks like this. You go to the clusters dropdown and do shell access. And if you log in with Access, you won't have to log in here again. This is just how the TAMU site works. Let me log in real quick. And yeah, logged in, it'll look something like this. Actually, I guess, since I got the error with faster via Access and not the normal one, maybe this is an access problem and not our fault. Oh well, so someone will fix it. Again, apologies for the inconvenience now. Anyways, moving on. You get onto ACES at some point. I mentioned briefly before, our job scheduler is Slurm. So to submit most of your workloads, you'll be creating files that look something like this. Normal shell script with a bunch of SBAT commands in there. We do also have some fancy job composer stuff on the portal that will let you skip some of the Slurm stuff if you want. We'll talk about that later. For now, though, if you want to use the fancy accelerators on ACES, the main lines you're going to be looking for are these partition and gres lines. I'll show you how these change in the coming slides. So first of all, composability. Composable cluster, how do you do that? Right now, to compose nodes in a given configuration, you'll contact us. That's handled by our sysadmins. So you can email us at help@hprc.tamu.edu, and we can set up whatever configuration you need. The ultimate goal is that you won't have to contact us. You will just specify what you want in your Slurm file back here, and it will automatically compose it for you. As it is now, it is still a manual thing by the sysadmins. Once it has been created, though, once your compose node has been set up, your Slurm file doesn't have to do anything special. You'll just ask for the relevant resources here. So this could be, GPU H100s 14 or whatever. Again, the ultimate goal is for that to be done automatically. That's something we're waiting on Slurm and Liquid for, though. One other note here is that most of the components are composable. Currently, the IPUs and, I think permanently, the IPUs and NEC vector engines are not composable. I think they have like connection issues or something. I forget the details. For now, though, let's go over briefly how you get to each one of these accelerators on the cluster. Most of them are in Slurm, and it'll just be a matter of choosing the correct partition and gres arguments. The ones that are not in Slurm are the IPUs and vector engine. Those will have some additional SSH steps in there. I'll show you details of those in a minute. So first of all, are two types of NVIDIA GPUs on ACES. I guess since I log into Faster here, I should tell you, Faster has a slightly different array of accelerators on it. It has some other GPUs, for instance. On ACES, though, there will be A30s and H100s. A30s are a bit smaller, H100s a bit larger. H100s are very popular. They tend to be busy a lot. To get these, you will specify in your Slurm job file the GPU partition, and the GRES line will look something like this. GRES equals GPU, the type you want, so A30 or H100, and then the number you want. I mentioned that the H100s are popular. There's actually another partition you can use, the GPU_debug partition. That one has a job time limit of 2 hours, so it's got faster throughput here if you just need like quick testing of something, for instance. The next one to talk about is our Intel Data Center Max GPU 1100 GPUs, or PVC GPUs for short. Similar to the NVIDIA GPUs, you will just specify a partition. In this case, they have their own dedicated PVC partition, and then a similar looking GRES line. The GPU type will always be PVC, and then just choose your number. We've also got a dedicated command line tool for checking their current configuration, this show PVC features thing. It'll show you what generation fabric they're in, XE-Link version, the numbers of PVCs per node, the status, etc. If you want to know more about these, we have another short course coming up on October 15th, where my colleague Genoa will show you more that you can do with PVCs. He'll go into a whole lot more detail than I can here. I believe we do also have a previous version of that training on our YouTube channel, if you want to see that sooner. Okay, next is the GraphCore IPUs. Now, what's an IPU? This handy little figure that GraphCore made illustrates it fairly well. If the difference between a CPU and a GPU is parallelism, GPUs more parallel, and IPUs even more parallelized, like a whole lot more parallelized. It also goes to multiple instructions instead of just single instruction. So again, you're working with your AI model of a bajillion parameters. Having this level of parallelism might be very handy. GraphCore's got their own documentation to see how to make use of these. We've also got IPU pages of our own on our knowledge base. Actually, yeah, let me highlight that again. I showed you briefly. So back on our knowledge base here, under ACES, we have pages for most all the accelerators. 2 pages for the 2 kinds of IPUs, showing you how to set them up and use them. All the other ones as well, plus general like cluster details, which I'll talk more about later. Let's see. To use the IPUs, these again are some that are not in Slurm. Once you're logged into ACES, you're going to SSH into these popular systems. Contact us first to be given access to those. Then there's some environment setup stuff which doesn't all fit on here. See the knowledge base pages for more details on that, and also for this GC monitor thing to check how your the IPUs are doing with your jobs. Again, though, if you want to know more, we have a training session coming up. This one on October 1st, also taught by Genoa. And again, I think we've also got previous versions of that on YouTube as well, if you want to see them sooner. Moving on, meanwhile, next is the NEC vector engine with the specs that I will not repeat back to you. We have previously had I believe it was a vector annealing class. Vector annealing, simulated annealing, or this person did Sudoku, whatever. We have one of these classes using these accelerators on our YouTube channel already. I don't believe we have another class planned for this semester, but if you're interested in one, let us know and we'll see what we can do. This is the gist of how you use them, though. This is another one that's not in Slurm. You SSH into this DSS system, do more environment setup, and run it like this. Again, see our knowledge base for more information. Next is Next Silicon coprocessors. These are back in Slurm again, which is handy. They just have a dedicated partition, Next Silicon, like this. Again, see our knowledge base for more. FPGAs, we have 2 kinds, as I mentioned earlier. Also in Slurm, they do have dedicated separate partitions for each one. So the bitware is appropriately named bitware, and the D5005 is in D5005. Again, both in Slurm now. I mentioned before, it's more than just accelerators you can compose. You can also compose memory using Memberge and Memory Machine. We've got a bunch of Intel Optane SSDs that you can tack onto your nodes to get more memory if you need it. This, once again, is just a dedicated Slurm partition, Memberge here. And again, see our knowledge space for more. Okay. That was the very quick gist of our accelerators. Does anyone have any immediate questions? Past this point is mostly going to be general, like ACES and cluster computing usage. So our knowledge base, which I've harped on a bunch, there's a lot of details about ACES, also a lot of details about just how to work on our clusters in general, account management, stuff like that, if you want to know more. I've mentioned our YouTube channel several times, which you can find at this link. Oops. We've got a whole bunch of previous short courses. We've got ACES dedicated playlists, stuff like that. The recording of this class will eventually make its way here as well, if you want to refer back to it later. I mentioned these already. We've got upcoming IPU and PVC classes if you want to know about those specifically, in addition to having some on our YouTube channel as well. Okay, let's keep moving. All right, so more generally then, maybe some of y'all want to know just how to work on ACES in general, how to do cluster computing in general. Let's go over some of those basics and get y'all up to the point of being interested in those accelerators later. So from the top, be nice on the clusters, don't violate our policies, do not share your accounts or passwords, do not share your file space as well. You'll set up separate shared space separately. I'll talk about that in a bit. Do not use the clusters in a way that's going to violate any export control laws, and if you're using any licensed software, obey whatever rules they have. So getting onto ACES, you need an access ID, access account, access credits, or you'll get temporary access by being in a training class like this one. The gist of this is create an account, which most of y'all have already, select opportunities and allocations, get credits, and exchange it for what we call service units on ACES here. That's compute time. You can find an application for ACES on the access site here. PIs can register. Grad students can also register with a letter of collaboration from their PI. I forget exactly which allocation levels we have. We have Explore and Discover for sure. I forget about Accelerate. Presumably you'll find that on the access site though. Explore is the smallest one. Move up to Discover if you have a bigger project to go with. Yeah, this is mostly all handled by access side, but let us know if you have questions. Okay, say you've got access set up, you have access credits to spend. What do you do with them? How does cluster computing work on ACES or in general? So in broad strokes, there are like 3 levels of computers you need to be aware of in doing cluster computing. You will, of course, interact mostly with your own machine. That is where you work on the portal, or if you're on Faster through SSH. ACES does not currently allow SSH access, be aware. When you log into ACES or Faster, you will first be on a login node. This is a relatively smaller node, which, per the name, is for logging in primarily. You will set up you'll do small amounts of processing and set up job scripts, which you would then send off to the final layer of computing, the compute nodes and back. These are where the big heavy lifting actually happens, and this is where you will spend your access credits and or SUs in our system. So everything you do in the login node is not charged. Everything in here is not charged. Everything in here is not charged. It's only once you send a job off to the cluster, off to the compute nodes, that you get charged. To access, I showed you all this already, but go to the portal dropdown, ACES portal, log in through access, and once that error is resolved, you end up on a portal that looks like this. Okay, let's talk about the basics of things that you can do in the portal. And okay, thank you, Wes. Wes says that we do support Accelerate allocations. Thank you for confirming that. So things you can do in the portal to start with. There's a bunch of tabs along the top. We'll go over each of those briefly. First of all, we have a file browser. So if you don't like the shell, a lot of the things you would do in there can be done in that browser. So here I am in the Faster portal again, but the ACES portal will be very similar. You'll have this file tab, and you start with a home directory and a scratch directory. You can choose either here, and it'll take a moment to load. And I have a bunch of junk in here already because I've been on here for a couple of years and had plenty of time to put junk in here. Yours might be empty, but anything you make in the shell, you'll see here. You can change to whatever directory you want. So say I do want to go to scratch. And now I have more junk, even more junk. From this interface, you can view files, edit files, create new files, download files, upload files, all the things you'd want from a file browser. And you can do all this without doing Linux commands if you want. So if you do prefer Linux commands, you can also just open terminal with that button there. I have one open already, so I'm going to close that again. Let's see. Next tab is the Jobs tab. I think I'll talk more about that later. Yes, I will. For now, the Jobs tab has several options. The two I want to draw your attention to are the Drono Composer and Drono Job Listing. These Drono things are new, like this year, past couple months. The Drono Composer, again, I'll have more to say about this later. This will help you set up jobs without having to interact with like Slurm directives directly. And the Drono Job Listing will show you like SQ information, running jobs, completed jobs, pending jobs. Again, I can demonstrate that more later. Otherwise, the active jobs and job composer stuff, that's older stuff, which I personally have not gotten much attachment to. Y'all can check them out if you want. Active jobs is similar to SQ again, and the job composer is like, let's just say, Slurm templates and similar. It doesn't really let you avoid writing all the sbash commands, though. Okay, next up is the Clusters tab, which I showed you. That's how you get the shell directly. Next tab is fun, the Interactive Apps tab. Say you want something visual. Where am I at? Oh, did I close my portal? Whoops. Back in the portal. Got these tabs. So I use Jupyter notebooks a lot. You can find those in here. Jupyter Notebook, Jupyter Lab, or any, well, this list will vary by cluster. I forget how ACES varies from this exact list. They do all have Jupyter notebooks, though. Might have a slide about this later. The gist of it is you'll fill out these fields here to set up your environment. You'll hit launch, and then it'll set up a GUI for you. It's a Slurm job in the background, but it'll let you interact here graphically like you normally would for Jupyter. Maybe I'll show that later if we have time. Let's see, moving on. Next tab is Affinity Groups, which will send you to, oh, not in the Faster portal, only the ACES portal. Okay, well, that will send you to some ACES groups, ACES web pages for more information if you want. I see a question in chat. Can ACES servers support data transfer between servers between two universities? You mean like transfer data from ACES to another university? I believe so. I mean, you'd have to have access to both by yourself, of course, but I think we'd point you to Globus Connect there. ACES has a Globus endpoint, and hopefully the other institution has a Globus endpoint as well, and you can send data through that interface. I have a slide for Globus at the very end somewhere. If you have more questions about that, I'll answer as best I can. Let's see. Another question in chat. Tried to follow HPRC Intro to Linux through Grace, problem with Tamu VPN. So Grace is only accessible to Texas A&M users and Texas A&M system users, I believe. If you're not part of the Tamu system, you can't get in even with VPN. If you are a Texas A&M student or staff user and you're having trouble with VPN, you'll have to contact Tamu IT about that. HPRC does not handle VPN itself, I'm afraid. Otherwise, again, if you're outside A&M, you're going to be limited to the clusters that have access options. So you can get into Faster and ACES and possibly launch. Contact us about launch. So if I may ask, are you at Texas A&M or another institution? SLU, okay. Then I don't think you can get into Grace unless that institution is related to TEMU in a way I'm not aware of. Yeah, Grace is only Texas A&M, I'm afraid. Okay, Keegan posted a link about VPN. Thank you, Keegan. All right. Back here, back in the portal, where are we? The dashboard, okay. Dashboard is fun. Dashboard will give you a summary of what the cluster is doing and also your usage on the cluster. Let me go ahead and show y'all that. All the clusters have it, so Faster will have something that looks similar to ACES. It'll take a moment to load. It'll show you how nodes are being used on the given cluster, and it will show you your disk quotas, which I'll talk more about in a minute, and it will show you your SU allocation. That is, your SUs are what correspond to your access credits. These are how much computing units you have to spend on the compute nodes. It'll also let you manage groups, and it's got a little job composer down here, possibly. I think we'll come back to this again later when we talk more about SUs. And file quotas, yes, right here. Okay, so I showed you all in the file browser. Y'all will start with a home directory and a scratch directory, which you can find in the shell with the home and scratch variables. Home is smaller, 10 gigabytes with 10K file limit. It is backed up though. In home, do like small amounts of computing, mostly just like save concentrated important things. The scratch directory, on the other hand, is much bigger and it's not backed up. It's got limits of 1 terabyte and 250K for files. This is where most of your like actual processing should happen. In Scratch, it can take a lot of files. It is not backed up though. So do all your Scratch work in Scratch and then save whatever important results you have to your home directory, or possibly take it off to an external drive or something. One other place to be aware of though, I forget the details. Wes Sandra, correct me if I'm wrong. I think if you come in through Access, you will get a project ID directory that will be shared. So the PI will get this shared directory here that can be shared among all their students working with them. Default limits are 5 terabytes and 500K. You can request extension on these as well. Talk to us about those. There's also, you can request extensions in the dashboard with these buttons up here. Okay. Moving on though, I've mentioned service units several times. What are those? Service units are what you spend to spend time on the compute nodes. I believe you'll exchange your access credits for these on ACES. One service unit is 1 core hour on a CPU. If you're using the accelerators, those will usually cost more. Well, no, not usually. They will always cost more. The accelerator is more expensive. The number of SUs you start with will depend on which access allocation you got, so explore, discover, etc. SUs are charged as your job to spend time on the compute nodes. We'll see how a little bit later. Again, though, you're not charged for being on the login node. So again, right now, if you're on a screen that looks like this, you're not being charged. Well, unless you did an S run here, I guess. But login node is not charged. Being on the portal is not charged. Launching jobs here, those will get charged. So Jupyter will spend units. You can check how many SUs you have to spend, both on the command line and the HPRC portal. I don't have a slide about it. Let me just show you real quick. So on the dashboard, your SUs are up top here. Here I've got 2 allocations, shows me the balance, shows me the amount used, and I can set which one is default. You can do those same things on the command line. So first of all, when you log in, you see your quota information here. If you do happen to lose it though, oh no, where did it go? We have a show quota command. And again, this is on all of our clusters. So I'm on Faster, ACES has this as well though, and it'll get you those quotas back again. Wait, I'm sorry, I got this mixed up. Show quotas for file space. So that would have been appropriate for this slide. If you want to check your limits on this slide, that's show quota. If you want to check your SU usage, my bad, it's my project. I always get this, oh, sorry. Put two in that, let's see. My project dash L. Did I blank on how to use this? Goodness. I thought this my project did this. Might be different between Faster and ACES. Okay, my bad. Point is, you can find this information. On ACES, I'm pretty sure just my project will do it. That's weird. Maybe I just blanked on it. Anyways, we might see more about this later, but I guess consider this an advertisement for the dashboard. It shows you all your quotas and whatnot, and you can request quota increases here as well. Account management, see more. Yeah, details. Okay. Not going to spend much more time on that. We have more information in our knowledge base again, if you want to see more. Okay. This I touched on already. When you first log into the cluster, you're in a login node. You're not being charged. You're not being charged because you're not doing anything big and heavy and, I guess, computationally interesting on the login node. When you're on the login node, no processes can run longer than 1 hour. Sessions that are idle for 1 hour will be killed. You cannot use more than 8 cores, and you also cannot use sudo because you don't have administrator access. If you need to run things that run more than an hour, that's a job. It needs to go to the compute node, and you'll do that with Slurm and whatnot. Oh, here's the slide. Okay, you can check your quotas with show quota and my project, right? So my project should have done something like this. For some reason, Faster didn't want to do that, and I don't want to spend time troubleshooting here. Normally, it will do this, though. You can set your defaults, check particular accounts, etc. Okay. Oh, yes, by the way, I'll just go ahead and increase this. Just wondering if my text was visible. Hopefully it is now if it wasn't earlier. Okay. So I mentioned SUs are normally 1 core hour. You get charged more if you're doing accelerated things. This is our basic charging scheme. You can find this on our knowledge base as well. Yeah, in both service units and access credits. I'm not going to read through this, but here's the slide for reference. Okay, let's talk about software infrastructure. We don't have exactly the same software between Faster and ACES, so my examples in here may not work exactly with me on Faster here, but the general infrastructure is the same though. So first of all, there's several ways to see what software is on each of our systems. You can do it on the command line, which I'll show you later. You can also get a first look on our website's software pages. Let me show you all real quick. Oh, this is different. I'm going to change it. Okay. Let me see if I can find it again. I was looking for a different page. Software. Module list. Well, gosh darn it, sysadmins changed it out from under me. All right, well, we have this list here on the website, and we also use lmod on the command line to find stuff. Question in chat, will the service unit start counting once we access the login node or only when we submit Slurm jobs? It's only when you submit Slurm jobs. Nothing on the login node is charged. Basically, if you try to do anything on the login node that would require charging, your session will just get killed. Like if you request too many, if you try to use too many cores, you just get killed. If you're running a process too long, it gets killed. Anything that would be worth charging for is going to be on the login node. It's going to be through a Slurm job. So on login nodes, don't worry about it. Okay. Modules. I was talking about modules. Let's see. Do we also have too many tabs? Let me also find the faster module list. Okay, this is what I was looking for. Looks like someone changed the ACES page, but for our other clusters, if you want, you have this little like search box here. So I'm going to say I want PyTorch. I'll type in PyTorch, and you'll get everything related to PyTorch, including, of course, PyTorch itself. It'll show you what versions we have and whatnot. One possible reason someone may have changed the ACES page is that be aware. I like this interface on the website, but this lags behind the actual software on the clusters a bit. So if you want the most up-to-date information, check it on the command line here. And you will do that with module spider, which I believe I have a slide for coming up. Yeah, coming soon. Okay, yeah, takeaways, this is a good quick look. You'll do more detailed stuff on the command line, though, and I'll get to that in a minute. Talking about software more generally, though, there may be something that you want on the cluster that is not currently on the cluster. So how would you get it there? You can install some things yourself, as long as they don't require sudo. If you do install something yourself, probably install it in your Scratch directory. Remember, Scratch is a whole lot bigger than Home is. And most software installations are going to require like a bajillion files. So you'll want to not blow out your home quota. If they do try to like install in your home directory by default, you can set up a symlink usually to your Scratch directory to sneakily put everything in Scratch where there's space. If you need help, or if you want something to be installed cluster-wide, like maybe you're collaborating with a bunch of people and they all need access, contact us in those cases and we'll see about installing it cluster-wide. We'll install it as a module, which I'll talk about in a moment. You can also specifically send requests for installations from the dashboard, which was up here. My Zoom interface is all over the place. Sorry, give me just a moment to organize. Okay. Dashboard. If you want software, email us at help@hprc.hammer.edu or click this button up here. And it'll ask you details for what you want, where you want it, so on and so forth. Okay, and lastly, licensed software. Licenses are myriad and complicated and annoying. Email us if you have questions or need help. You may need to contact like whoever owns the license though, because like the license may cover only you, or will cover a bunch of people for a limited amount of time, some amount of space, yada yada. Contact us if you have questions about license things. Okay, so computing environment. We manage software versions using lmod and do a lot of commands involving the word module. All the cluster-wide stuff is available as a module, and when you look at them on the command line, it'll look something like this. So module or toolchain name, their version. I just want to get to examples of these. Okay, let's start with module avail. What things are available to you? You just type in module avail and it will show you. Module avail. And this may be a lot. It will be a lot, yes. So these are all the modules that you can load up, or I can load up right the heck now. It's a bunch of them. I'm not going to look at all of them. If you're in this interface and you need out quickly, hit the Q key, and then my prompt is back. You can also do the MLA command, and it will do something similar and save it to a file. I don't know if I have that file already. Do I? I don't. Okay, so I will do MLA. It will print out some available modules and also save me a file that I can like grep through later if I want. So here's all the things that are available in a relatively simple list, and it has also created, in this case, a module avail faster file. On ACES, it'll be module avail ACES or something. And in this file, I have that same output I just got, so I can search and edit and grep if I want. I believe you can also do specifically, like give it a specific software to look for. Yeah, same thing. And it put it into that same file again, though. So this gave me everything related to PyTorch. All right. If you don't want just everything and you just want to search, you can use the module spider command. So this is the better version of what this website is doing here. Module spider will module spider on the command line will always give you everything that is actually there. So this person's looking for Python. All right, let's just do PyTorch again while I'm at it. Module spider Python. No, sorry. Well, sure, Python while I'm here. The problem with Python is that everything is related to Python, so you kind of get everything back. Let me just try PyTorch again. Should give me a smaller amount. Okay. Still some other things that aren't directly PyTorch, PyTorch related, but also PyTorch itself. And this output is showing you all the particular PyTorch versions that we have. And if you want to know how to load any one of these, you will use the module spider command again. So say I want PyTorch 212 CUDA 1211. I will do module. Actually, first let's check. The way you load a module appropriately is module load and then name of module. Does this work? No, it does not. And it even tells me what to do. Try module spider, that module, to see how to load it. So if you ask for something general from module spider, it'll give you this big list like we saw. But if you want to load something specific, you can give it that specific named version. Oh, jumped ahead for me. And it will tell you exactly how to load it. So it didn't let me load this particular PyTorch. And that's because I need to load these particular underlying modules first. You see, it says here, you will need to load all modules on any one of the lines below. Some software will have multiple lines in here. This one just has one. But it's telling me I need to copy these modules and load those first. Module, load. And you can do them all on the same line if you want. Just make sure they're in the correct order. Load, GCC and OpenMPI, and then PyTorch. And this will work. Takes a moment. There we go. No messages back is good. That means no errors. And then say we want to check what we have. I might be jumping ahead. We have, yes, this stuff. So module load to get the stuff you want, then module list to see what you have loaded already. So module list. And I do have a bunch of things because there's a bunch of dependencies and whatnot associated with these modules, but we loaded GCC 1230. There it is here, number 4. OpenMPI. I don't feel like looking through all this. We ultimately wanted PyTorch CUDA, right? There. Whoop. Zoom, stop it. Zoom is giving me windows everywhere. PyTorch, that PyTorch we wanted, finally down here. So we got all the stuff we wanted. We have all the dependencies it had. We're now ready to do PyTorch things. This is, however, kind of a mess. What if I want to work on, another project, something unrelated to this? I don't want all this stuff cluttering up my path, cluttering up my system here. The way you get rid of all this is module purge. This will reset me back to clean working environment. If I do module list again, it's all gone. No modules loaded. I'm back to basics, and I can load whatever I need for my next project. We've also got shorthand, by the way. You can just do ML for module list. Yeah, you can also do ML purge, and I believe ML. Actually, does it replace the load as well? If I do ML this stuff, I forget exactly. Oh yeah, ML just does everything. Okay, so ML is nice shorthand for all this module stuff. Now I want to list, do ML. Look, it's all back. Want to get rid of it, ML purge. Different moments, ML again, and it's gone. Okay. Cool. So ML is handy shorthand for everything. But these are the underlying commands, module, whatever. All right. Well, I wanted you all to have a chance to practice with this yourself because it's a lot of moving pieces. But if ACES is hamstrung at the moment, that's going to be difficult. Well, this slide is here for reference if you want. Come back and check this later. You can practice loading up this BLAST software. And this is doing all the stuff I showed you. Oh, actually, there is something new here. Okay, let me run through this really quick, because there's something about the module system I want to show you. And then I think after this, we'll take a brief break. I hope all these software versions run faster, because I checked for ACES. So I want to look for this blast software. Oh, is ACES working? Someone says ACES is working. Let's try it. ACES portal access. Ooh, cool. Okay. So I made it onto ACES. All right. Slight schedule change then. Y'all following along? Y'all try to log into ACES too. Let's make sure we can get there. Once we see that people are on, we'll go ahead and take that break, and then we will practice with the modules after we come back from break. Okay, Sued's on already. Yeah. Everyone else try to get on. To this point, again, the shells up here under clusters. Let me know once you get on. Let me know if you have further problems, and we'll try to get everybody on ACES to practice this stuff. Okay, everybody. It is now 11:10 Central Time. I think we're going to go ahead and keep going. Let's see. So in chat around break time, we were talking about file transfers, and I recommended Globus again. I posted a couple links in there to our knowledge base showing Globus as well. I think I might have time to demonstrate that. We'll come back to that a bit later. For now, if you're interested in file transfers, the main thing is, since we don't have SSH into ACES, you can't use like FTP or rsync. So usually we point people to Globus. It's good at handling like big data transfers and whatnot. Again, I'll try to demonstrate that later if we have time. For now, though, since we have ACES working now, it sounds like Access fixed something on their side. Now y'all can follow along with me and try out some of the software module setup stuff with me. So follow along as best you can. Say we want this Blast Plus software. First of all, actually, starting from the top, in case you lost it, to get onto ACES, now that it's working, go to our homepage, hprc.tamu.edu, hover over the portal, go down and click on ACES portal access. I'm logged in already, so it doesn't ask me to log in again, but if you haven't logged in, you'll log in through Access and your institution. You'll end up on the on-demand portal like this, and then to get to the shell, go to the clusters tab, then ACES shell access, and it'll look like this. Okay. And probably if you need larger text, Control+, something like this. Okay, so we want to load up that Blast Plus software, and we're going to follow along with this. So first of all, see what is available. This one is doing MLA, so this is the thing that both shows you what's available and also saves the file for you. So we're going to do MLA Blast Plus. And actually, I'm pretty sure I have that file already. Yeah, so I have a module avail ACES. I'm going to go ahead and get rid of that and make a new one. So Blast Plus, MLA Blast Plus. And it tells me we have these two options, and it has saved it to this file. Go ahead and check. Module avail ACES. Oh, it's everything. Sorry. I guess if you wanted, then rep blast. Throws me right for trying to improv. What did I do? It's not in there. Okay. I have no comment. I'm just being a fool. MLA Blast Plus, it tells us we have these two. I don't want to troubleshoot right now. We want to load up, what the example say, we want to load up 2.14.1. Can we do that? ML 2.14.1. It didn't work. This error was intentional. This is not me messing up. We want to figure out how to load this. Luckily, it tells us what to do. Module, spider, and then that version. So I'm just going to copy this. And it shows us for this version, we need to load up this GCC and this open MPI. So I will just grab those, module load or ML shorthand, and then I'll just tack on blast plus at the end. Okay, no error message, it worked. We're going to check it with module list or just plain ML. Okay, a little bit fewer modules than I had in my last example, but we see there's still some dependencies that were dragged in here. But we loaded GCC 1230, here it is number 4. We loaded OpenMPI 415, there it is 16, and we loaded up Blast Plus, which is, am I blind? Or is the, yeah, Zoom window's covering it up. Okay, Blast Plus 214.1 at the very end there. All right. I have multiple monitors. Let's get all this Zoom crap out of here. Okay, so got everything we needed. What was new in this example that I wanted to show? Right. So remember, it didn't let us load up Blast Plus because we needed to load that particular GCC and OpenMPI. What if we yank that out from under it and put a new one in? What if we put in GCC 10.2.0? Because again, we're trying to switch to another project now, and we need these other dependencies for some other software. What if we do module load GCC? What was the example? 10.2.0. 10.2.0. So this is some older version. For Blast, we loaded up 12.3.0. Now 10.2.0. What happens? We get several things. We get a whole bunch of inactive modules, including Blast Plus, the thing we wanted. Something went wrong here. So I was trying to be helpful. Some modules have been reloaded, and we have these modules reloaded with a version change, including the GCC stuff we just did. This is basically an advertisement for module purge. Again, if you want to switch what you're doing, purge your environment. Don't just load up the new modules directly, because you're going to get into a complicated situation like this where the things you want don't work. Better to start from the bottom and build up for whatever new project you want, and then to switch, purge, move over, build up, etc. So I'm going to module purge to clean up this mess. Module list, okay, all clean. And now if I wanted Blast Plus, I would just do that first set we did here. And if I want something else, I would purge before loading up another one of these compiler tool chains. Yeah, I don't guess I included the slide here, but the point is our modules are hierarchical. Sorry, terrible word. Our modules are hierarchical. That is, some modules are built on other modules. So Blast Plus was built on top of these particular GCCs and OpenMPIs. We can't yank it out and put another one in because Blast Plus was not built on some other one. It is built on this exact one. So be careful mixing up compiler chains and dependencies and whatnot. Okay. Was everybody able to, I guess I was switching away from this. Was everybody able to follow along? Is everybody able to get through these steps here? And so Module Spider, from the top, Module Spider can do two different things. So yeah, Module Spider in this sense is mostly a reminder of dependencies. To summarize though, Module Spider can do two things. If you do Module Spider and then the generic name of a software, it will search. It will find all the things with that software in the name. So in this case, it's only Blast Plus. If you give it a specific version, so in this case 2.14.1, giving it a specific version will tell you what you need to load it and give you some more details about that version. In particular, you're usually going to be looking for this middle segment here. You will need to load all the modules on any of these lines, which in this case is these two together. Off the top of my head, I wish I knew an example of something with multiple lines, which is a good example. Because other software will have so this is one line. They'll have more lines after that showing alternate tool chains that you could build on top of. This one just has the one. point is the second use of module spider, given a specific version, you're usually going to be looking for these dependencies in the middle. Once you have those, you can load those dependencies and then whatever you ask module spider for. All right, and then module list. Here I am. Okay, that helps. Let me know if you have any further questions. Okay. I'm going to, meanwhile, purge all this in case we do more. Okay. So any other questions on this workflow? I guess I should say as well, you can put these commands in your job files. In fact, that's usually what I recommend. Your Slurm job files can pick up the stuff you have in your login environment. I would say don't do that. Usually you'll want to start your job files with a module purge to make sure you're starting from something clean, and then module load the exact things you need in the job file. The reason I'm suggesting you handle your module stuff in the job file is to help with reproducibility. You don't want to submit a job that relies on the particular environment you launched it from, because then it's going to be impossible for people later to reproduce it, because they don't know what your login environment was. Okay. Speaking of batch computing, let's talk more about that. So I showed you all an example job file like way back at the beginning. Here's another one. This one not Accelerator specific. Writing Slurm job files, it will be something looking like this. It is Sandra asked me to share my screen. I believe I am screen sharing. Y'all not see it? Okay, JavaScript though. Question in chat. Before submitting official Slurm jobs, are there any quick test nodes for us to test all commands on terminal instead of on login node? I mean, it'll depend what exactly you're testing. If you can, okay, shut up, Sandra, that's good. To test stuff before submitting to login nodes, I guess you have several options, one of which I'll get to later. Do I have an example job file? I have a slide about this later. First tool that may be helpful is maxconfig. Maxconfig generally, it'll show you like the maximum parameters that your job file can have, like on a single node that is. So maxconfig by itself, this defaults to the CPU partition, and these are the maximum SBatch commands you can give. You can feed it, however, a given job file. I think I have a hello world in here. Yeah. And it will, ACES SU calculations, charging is still being turned on. Okay. Once SU charging is turned on, so right now you can run things for free because SU charging is not on. Once it's turned on though, maxconfig will let you estimate based on a job file how many SUs it will take. More generally to test stuff though, like to see if it'll work. Usually what I do is just like submit on the command line, like without a job, I submit like a tiny job just to check that all the commands work. So like my background's in physics, for instance. If I'm running a particle physics simulation with, you know, a million atoms I'd want to submit to a compute node. If I just want to check that the commands work, I'd cut it down to like one atom and submit it on the command line. But like you can do small computing on the login node, I should say. How you would test like the full million atom sample, how you would test the full amounts, there may not be a good way to do that. Like my general recommendation is just scale down, then scale up from there. Does that answer your question? I was kind of rambling a bit. I guess if you have sample data, like small sample data, that's possibly something you could run on the login node. I guess unless you need a GPU. Okay, so it helps a little bit. I guess I did mention briefly, we do have, so this isn't free, but we do have a GPU debug queue. If you do need a GPU specifically, but you need a small job, we have a dedicated queue for like jobs that take a short amount of time. So you will get charged SUs for that once that's turned on, but this is a relatively quicker place where you could test something out if you absolutely need an accelerator. Otherwise, yeah, I'd say just scale down, scale back up. Okay, where was I? Yes, jobs, Slurm, looks like this. So your basic Slurm script is a shell script. It's got a shebang at the top, and it's got normal stuff that you type into the command line below. What's new is all these fbash commands. They start with the pound sign, so the shell will think they're comments, but Slurm knows better. Slurm knows that these pound fbash commands are like job parameters. These are what tells Slurm what resources you want. And I should say as well, since I kind of mentioned it, you can actually submit a job script just on the command line, because like it doesn't care about the file suffix, and the shell will just ignore these. I might have an example coming up. Yeah, I'll show you in a moment. Actually, yeah, I'll show you now. The way you submit a Slurm script is with the fbash command. So if this file here was called example01.job, you would submit it with fbash example01.job. If it is submitted successfully, it will give you a job ID and it'll tell you the number of SUs charged. Once it's running, you can check on its status with SQ. SQ by itself will give you like all the jobs on the cluster, everybody's jobs. You probably don't want that. So normally you'll want to do SQ-U and then your username. You can use the user variable or just do SQ-me. Do I have an example? Okay, I'll just show you really quick. So I happen to have in my home directory, actually, do we have these shared? Let's see. Do we have, oh, I'm not seeing it. Oh, maybe. Is it in here? It's not quite the job I was looking for, but maybe it'll work. What is this? It's tiny and boring, but maybe this will work. Actually, yeah. We'll make this work. I'm going to make this job file something y'all can copy. I mean, I think you can copy it now, but I'm going to add in, just sleep for a little while. I didn't check this beforehand, so sorry if this doesn't work. But if y'all want, you can copy this job file to your home directory. Let me put the link in chat, or the path in chat. If y'all want to practice with Slurm, copy that file to your home directory. So that'd be copy that file home, that is tilde. I have it there already, so I won't do that. Okay, this might have been copied from a different file. Oh, this is a different file. Okay, that other file works. Copy that job I just showed you. So copy this home. This will overwrite. No, it won't overwrite because they have different tags. That's fine. So hello world.job. You have this in your home job. You should have this in your home directory now. We're just going to submit this just to see how it works. So fbatch hello world.job. Okay. Tells you the account it was submitted from, tells you the balance, tells you the job ID. If now we want to check on what's happening, SQ-me is quickest, and there's my job. You see it's got the same job ID it told me before, tells me the job name, that was something set in the Slurm file, tells me the user, which is myself. It's in the CPU partition, it's on one node, one CPU, currently it's pending. Okay, now it's running, tells you the time running, time left, when it started. Oftentimes, if it's pending, the reason field will tell you why. So like, if you ask for GPU and all the GPUs are busy, the reason will say, waiting for resources or something. Once this has gone through though, okay, now the job is gone. That means it's done. My home directory is a mess. Let's see. where did the output go? That's also specified in the file. Level.job. The output goes to standard out, and then it goes to standard out dot job ID. This %J is Slurm lingo for the job ID. So that would be this file over here. Let's check it out. STD out job ID. Nothing. Oh wait, hold on. Did the job send it somewhere else though? It did. Okay, sorry. So there's no output. I didn't echo anything. What we did, sorry, I did echo something, but I redirected it to example output.txt. And I do have that. Yes, I have that as well. X output.txt. There it is. Okay. I guess for sake of demo, if I did just echo something out to, standard out without sending it anywhere else, make this identifiable. Okay. Let's resubmit that job. Sbatch hello world.job. Okay, same stuff as before. New job ID makes sense. Just for sake of demo, you can do, what was it, -u? Yeah, -u. And then use the user variable to get yourself. Okay, this job is running already. I mentioned before, the reason you might want to specify the user is because SQ by itself will give you just everybody's jobs, and you presumably do not want all these. Let's clear this. SQ-SE. Okay, that job's done. I should now, in my new output, which is this one with the higher job ID, have hello world again, the thing I asked for, I guess, and this EX output file still has the stuff I redirected to it. Okay. In chat, can't open file. It's not able to find a hello world.py file. Do you have a .py file? So mine is a mess. I have a hello world.slurm, hello world.py, and hello world.job. .job is the one to copy at the moment. These other two are, I think, left over from a previous class I did. I want to show you something new that is job related. So if you work on the command line the whole time, you're probably going to be submitting Slurm files like I just showed you. My problem with Slurm files is that stop it. I hit the scroll wheel accidentally. Okay, sorry. My problem with Slurm files is that I never remember all the sbatch parameters. And like, depending what you're asking for, there's different ones to put in here. The way I historically solved that was by just having a job template, something like this, and I just copy it into every new file I need to make and then modify it from there. We have some way to streamline this, which I think I touched on briefly, and that is our Drono Composer. It looks like this. Let me show you how to get there. This was back in the portal under jobs. So you have these 4 dropdowns here. And the ones we're going to look at are Drono Composer and Drono Job Listing. Start with Drono Composer. The Drono Composer will look something like this. And I showed you something like this on Faster. Actually, ACES has the newer version of the Composer. So it's good that ACES works. So I can show you the most up-to-date version. The Drono Composer will save you some of the hassle of the sbatch things. It will just give you a nice little form here to fill out to determine what needs to happen. So at the very top, determine a job name. I will call this test job XYZ. I might have other test jobs mucking up my environment. Test job XYZ, you see that it changed this location down here. So the files it creates will be in your Scratch directory at this path. You can change this to be somewhere else if you want. You can put it in home or shared group directories or something if you want. I'll just leave it in Scratch for now. And then there is environment in this dropdown here. We're going to be adding more to these. I believe we have a dedicated like AI ML environment coming here soon. For now, though, I will just choose generic. for sake of demo. And you see that this form has not been, not filled out, but this form has appeared with particular fields. Whereas if I selected the R environment, you get, oh, well, these are the same. My point is that these environments are customizable. We're adding new ones here, and you can change them yourself. I think we have some info on our KB for that. Once there are more specialized environments, these fields will change, and these fields all correspond to particular things that will be in your Slurm job file. And this includes stuff that you'd specify as shell commands, including like modules you load, but also all those fbatch commands. So total memory, total time, number of tasks, stuff like that. This form will fill that out for you. So arbitrarily, let's get Python in here. Start typing, it'll give you suggestions. Let's get the latest Python. Add that, you see it's been added, cool. You can remove it if you want. I'll just add it back in. Number of tasks, I'll stick with 1. Include advanced task distribution options. I don't really want to mess with that, but you get like number of nodes, for instance. By default, it'll just give you 1 node. Do I want any accelerators? Not right now. I'll just stick with none. Total memory. Most of these you can leave blank and it'll choose defaults, but I'll go ahead and choose 1. Expected runtime, 2 minutes. Project count, I'll leave that as default. It'll figure it out. Additional Slurm parameters, no thank you. Once you've filled out whatever you want, click on preview, and you get a preview, but it's not just a preview, it's editable. Lovely. So this is the Slurm job file that will get submitted. And you see it's filled out all the fbatch commands for you, so you didn't have to remember them. You could change them if you want, though. It has loaded. Oh, wait, I didn't add that Python in there. Oh, wait, that was wrong. Hold on. Wait, abort. Oh, well. I accidentally submitted the job. That's fine, whatever. I meant to do something else. Test XYZ2. Generic. I wanted to get Python in there. I think I forgot to add it. Yeah, add. Be sure to add it. Make sure it appears here. No accelerators. Let's just leave defaults. Okay, preview. Right, this is what I was looking for. So that job I just submitted didn't have Python in there because I forgot to tell it to add it. Be sure you've added it. You'll see all the modules you load here. Remember I said that before you start a new project, you'll want to do like a module purge. You see that has it in there automatically to make sure your environment's clean. It loads a web proxy, which you may not explicitly need, but the compute nodes don't have internet access by default. Web proxy gives them that in case you need to like download something else in your main script. Here's the Python I told it to have. It CDs into the directory created for me, and now I can add stuff below that. So echo hello again world, and that'll be it. This driver tab up here just shows you like how it's submitting it, or like the setup for it. Mostly I just edit this preview file. Now I'll submit. Okay, tells me to submit the batch job, gives me the ID. And now the job is running. If I have time, you can find it on the job listing. Since the command I gave was trivial, I don't think we'll see it running, but this is the Drona job listing. It shows you not only running jobs, which I have none because that one was tiny, but it shows you past jobs as well. You can specify the time frame you want to check on. If you have a job that's pending, you can find that here as well. This is just a nice, relatively user-friendly interface for SQ, you might say. You see I've got a bunch of other test jobs I've been running. Yeah, here's those last 2 jobs I did. Press sub if you want. To be clear, though, I mentioned that they go to a particular location that you specified. We'll show you that. I put it in Scratch. It was a job composer folder, right? Here's all the jobs I've submitted through the Drona Composer. The one I just submitted was XYZ2, I think. And here you find your out file, your error file, if anything. I don't think there's an error, was there? No, it's empty, just there by default. It shows you the job file, that it showed you in the preview, so you can submit it again here if you want. It shows you that driver script that had in the other tab, and shows you your output, which is just hello again world. I guess while I'm thinking about it, let me show you another way to copy. In case you're newer to like shell commands, you can also move stuff using this file menu in the portal. I'm going to delete this because I'm going to put it in here again. What was the job? Yeah. Get this. So if you want to do the copying in the file browser, you can change directory to where the thing you want to copy is. That was scratch, training. Actually, this might let me go in here by itself. Yeah, and then what was it? It's like intro to ACES primer. That was a separate class. I'm stealing this stuff. So you navigate to this directory to copy stuff in here. Check mark the job you want to copy. Hit the copy move button up here, and you see you get a sidebar over here on the left. It's basically like picked up the job file, and now it's telling you to go somewhere else to drop it off. What I want to do is move it to my home directory. So I click on that. You see now this over here is changed. It's still got the file I'm copying. Now hit the copy button again, and it'll add it in here. There it is, hello world.job. And then if you want, you can even edit it in here. Yeah. So load. Save button. Okay. And then you can submit this via, then you can submit it in the terminal once the file's there. I wonder, does Drona, I guess Drona doesn't submit new files. Like sorry, it doesn't submit old files. It just creates new ones. Okay. Maybe that's something we could add in. I'll ask people about that. All right. Okay, where was I? Anyways, yeah. Job files here where Jonah told it. Went over this. This was the preview. This was the job listing. Okay. So yeah, Drona is an alternative to command line things. Use whichever you prefer. Drona, we're still like adding stuff to. So it's going to get even better. Outside of submitting jobs themselves, let's say you need to check what is available to you, to ask for in jobs, to put in jobs. There's more than just these 4 commands here, but I want to show you these 4 commands really briefly. Max config is that one I showed you a while ago. I'll reiterate that in a moment. Starting off with sinfo. So the jobs you submit, either by SBatch or Drona, or even those interactive GUI jobs from the portal, those all end up in a batch queue somewhere. These are the ones we have on ACES. Let me just go ahead and show you. And you all can do this yourself. You should have the same results. sinfo, just plain by itself. And it shows you all the partitions that jobs could end up in on the given cluster. If you're working on a cluster other than ACES, you'll see a different set of partitions here. But this is what is specifically on ACES. So CPU queue, GPU queue, and then remember those special accelerators have their own queues. You see those again down here: PVC, Bitware, Member, Next Silicon. Staff you probably won't have because you're not staff. I am staff. For each of these though, tells you their availability, tells you their time limits. So I mentioned, for example, the difference between GPU and GPU debug is that GPU debug is for shorter jobs. You see it's got a limit of 2 hours, whereas GPU has a limit of 2 days for jobs. Shows you the different job sizes allowed. And then these last 2 columns, for nodes and CPUs, it shows you these AIoT columns. Those stand for active, idle, offline, and total. My formatting got gross here. That's a pity. Oh well. Active, that first column, A, shows you the things that are being used like right now. That is, things that you cannot use for jobs. So right now there's over 3,000 CPUs being used on 43 nodes in the CPU queue. I, meanwhile, is idle, things that are available for you to use. So for example, there are no free nodes, but there are about 1,000 free GPUs in the CPU queue. O is offline, that is like down for maintenance or something, and then T, total, sum of everything else. And it's got this breakdown for you for each one of these queues so you can check which ones are busiest. Next up is PE stat. So if sinfo showed you information for queues, PE stat shows you information for nodes. And it'll give you a lot of output, which is why I had a screenshot here, but now I can just show you PE stat by itself. Tons of information, tons of very colorful information. What it's showing you is the status of each individual compute node. So back up at the top here, actually, I'll clear this for clarity. PE stat, oh, it didn't actually clear it. That's annoying. All right. Where did I start? So from here, I did PE stat. The first column is the host name. These are the names of the nodes, AC1, 2, et cetera, et cetera. And you see there's a lot of them. So oftentimes for PE stat, you'll want to narrow it down a bit using some of its options. It shows you the partition it's assigned to. So first 1 and 4 is memberage, a couple staff queues, bunch of CPU queues, et cetera, et cetera. Node state, idle, mixed, drained for maintenance, et cetera. In use, total, load, size, yada, yada, yada. You may be interested in the job list at the very end. It shows you all the people running jobs on each node. That is, which nodes are busy and that you're unlikely to get space in, for example. You can narrow this down using options, as I mentioned. So using the -p flag, you can specify a partition name. You can do the -u flag with the username to find only a specified user's jobs, like if you want to check your own, for instance. And if you want to see details about GPUs being used, you can use the -g ops. So for example, let's say I want to check the GPU queue and see what GPUs are being used. Remember, there's 2 of them. There's the A30s and the H100s. So -p GPU and -g to show me the details. Okay, so here are the nodes in the GPU queue, and it shows you what GPUs are being used by the given jobs. So this one's got 8 H100s, this one's got 2 H100s, this one's got 1 H100, etc. Okay, so sinfo was queues, PE stat was nodes, GPU avail is appropriately going to tell you what GPUs are available. And its output is a little less much than these other ones. So GPU avail, we'll just give you a table or 2. Still kind of a lot because we've got a lot of accelerators, but not tons of things. It shows you what configuration we have at the moment. If you request, that composed node with 16 or 14 GPUs or whatever, that would be a different entry here. This set here happens to be what we have composed at the moment. Question: what does CPU load information represent? That was, honestly, I forget. I want to say that's the efficiency or something. I wonder if man PE stat tells you. Nuts. PE stat help. Let's see. Does this mention? Okay, I'm not seeing CPU load on there. I'm afraid I forget at the moment. That might be in our knowledge base. Wes, Sandra, do you all happen to remember what CPU load is in PE stat? Okay. All right. Sorry. We forget at the moment. We don't have any sysadmins in here, do we? They would know. No, I don't think so. Okay. Sorry again, though. Check our knowledge base. It might have more details. So GPU avail, again, this shows you what things are composed. And it also does give you some node breakdown showing you what type of GPUs they have, what's available, memory available, etc. Okay, and then lastly, this is the thing I showed earlier. This shows you this shows you SU usage details. So max config by itself, I showed you on faster earlier, didn't I? So this will be a little bit different at least. Max config just by itself shows you by default the maximum parameters you can ask for on the CPU partition with one node. You can change this up. Let's see, the slide doesn't specify, but you can specify like which partition to use, and also I think number of nodes even. What's particularly useful though is giving it a specific file. So I have, well, here's a job file. I can do that again. Max config -f for file. This is that test job I made with the Java composer, and this will be like, no, I forgot again, because SUs aren't being charged. This won't show anything. New stuff as well. Okay. This is something that admins fiddle with sometimes. Actually, so let me just try a different job file. I had that employee job file I had y'all copy earlier. There it is. Okay. No, wait, did it wrong. -f. There we go. This would show the SU calculation if SUs were being charged. So once that happens and you're not getting stuff for free, you can check here and see how much it'll be. Having max config here made me think of something that didn't work on faster that I wanted to show here. What was it? Was it my project? Right, yes, okay. Okay, so this is jumping back a ways, I apologize. Remember I did my project on faster and you didn't get a table back. This is what I was thinking of. It shows you the number of SUs you have, defaults and whatnot. I wasn't expecting it to be different on faster, but I guess it is. Once again, if you need to know how many SUs you have, you can check on the dashboard as well, which was not that dashboard. This dashboard, which will look about the same as it did on faster, just with different numbers. Yeah. Okay, so yes, here is my SU usage on ACES, which is currently nothing because it's not being charged. Same information here. All right, I'm jumping around. Message from Weston chat. CPU load is taken from sinfo. Percentage of CPU is being utilized at a given moment. Ah, okay, yes. I thought it was something percentage related. I just couldn't think of what it was. Yeah, so see, like none of these are above 100. That makes sense, okay. Oh, nope. There's a 500 in there. All right. It's something like that. The colors mean something as well. Again, check the knowledge base because I'm just riffing at this point. All right. All right. We're just about done. I mentioned Globus before. Globus is a good way to transfer files between systems, be it like, ACES and another cluster at another university, or also your own computer if you need to. The interface looks something like this. In these screenshots, this person was transferring between the ACES cluster and the Grace cluster, which is our other Texas A&M only system. When you log in here, it'll give you just like the list of things on your in your file system, and you can choose to move them over and whatnot. I think this is the last thing, so I might have a moment you have to demonstrate that. Let me see if I can demonstrate Globus really quick.